Hello all, in today's lecture, we are going to discuss an important topic in database management system. It is serializability. And in serializability, we are going to learn conflict serializability and view serializability. Firstly, what is serializability? A schedule in an order of multiple transactions executing in concurrent environment. Serial schedule. A schedule in which the transactions execute one after the other is called serial schedule, and it is consistent in nature. So why the serializability concept is introduced is, in the earlier class, we have learned about the concurrent executions, right? What is concurrent execution? What is concurrent execution? Multiple transactions takes place at the same time, right? More number of users are able to access the same database at the same time in order to perform different types of transactions. That is termed as concurrent execution. So when concurrent execution of transactions takes place, sometimes it may lead to different conflicts. As we discussed about write, write problem, write read problem, and read write problem. So in order to avoid these kind of conflicts, serializability concept has been introduced. So it is saying that it ensures in allowing the concurrent execution of transactions, but the operations of the transactions must be in a order. Like we have read operation and write operations. Whenever a transaction is to be executed, we perform operations like read and write. So when multiple transactions are simultaneously running with each other, this schedule or a serializability schedule says that the operations of multiple transactions must be in an order in order to avoid such kind of conflicts which we have discussed in the last class. So here firstly, what is a schedule? Schedule is an order of multiple transactions executing in concurrent environment. It is telling about the order of multiple transactions. Multiple transactions may take place, but it must be done in an order. Serial schedule. The schedule in which the transactions execute one after the other is called serial schedule, and it is consistent in nature. Here we have an example for serial schedule. You can see that there are two transactions T1 and T2. T1 transaction has performed read and write operations on the data items A and B. Once this job is finished, T2 transaction performs its operations on the data item A and B. So if one after the other the transactions has been executed, then there is no matter of conflicts here. Obviously, the data will be consistent in nature. Clear? This is about the serial schedule. And next coming to non-serial schedule. So the name itself suggests what? One transaction execution will be interleaved by the other transaction when they are concurrently executing with each other. You can understand what is non-serial schedule by taking this example. Here, T1 transaction performs read and write operations on A, and T2 transactions entered in order to perform read operation on A and write operation on B. It is performing read on A and write on B. And then you can see T1 transaction is performing read operation on A and write operation on B. Here you can see write operation on B is made by T2 transaction as well as T1 transaction before it commits. So this kind of interleaving transactions may lead to several conflicts. That is non-serial schedule. You can see the statement over here. The above transaction is said to be non-serial. What is serializability? So far we have seen different types of schedules and that they are serial or non-serial. Clear? Now here we are going to define the serializability. It is a property that ensures a concurrent execution of set of transactions produces the same result as if these transactions were executed one after the other without any overlapping. Serializability ensures that even when transactions are executed concurrently, the database remains consistent, producing a result that is equivalent to a serial execution of these transactions. So serializability is a property which ensures in the execution of multiple transactions at the same time. And when these transactions are executed, it produces the result same as the result we obtain when the transactions are executed one after the other. So that is about the serializability. Testing for serializability in database management system. How do you have to test the serializability in DBMS? Here, it involves verifying if the interleaved execution of transactions maintain the consistency of the database. Why do you have to test the serializability is to check whether the consistency is maintained in the database or not. The most common way to test serializability is using a precedence graph. We are going to learn what is precedence graph in the next slide. And we have two types of serializability, namely conflict serializability and view serializability. Let us see what are they. Conflict serializability. Two operations are said to be in conflict if they belong to the different transactions, they access the same data item, at least one of them is a write operation. Let us understand these 3 points by taking these two different examples. Here is an example which shows you the conflicting operations. And this is an example which tells you about the non-conflicting operations. Firstly, we have T1 and T2 transactions. And you can see read operation when performed by T1 on account A, write operation is performed by another transaction T2 on same account A at the same time interval. So when read and write operations takes place on the same account by different transaction, it leads to what? A conflicting operation. Write operation made by transaction T1 on data item A. Read operation made by T2 transaction on same data item A. And again, this is what it is a conflict. When some operation is made by one transaction, T2 transaction is not allowed to perform the operation at the same time. Clear? If it does, then it leads to a conflict. And coming to the third one, write operation made by T1 transaction on data item A, and again write operation is made by T2 transaction on the data item E. So this is what it is, a blind write. Both the transactions are performing update operation on the same data item at the same time. Then this again leads to a conflict. So these are the different types of conflicts that may occur when we allow multiple transactions to execute on the same data item at the same time. Okay, and here we have different transactions performing different operations at the same time, but these kind of operations may result to a non-conflicting operations. Let us see what are they. Read operation performed on data item A by T1 transaction and read operation performed by data item A by T2 transaction. When multiple transactions perform read operation of the same data item, it does not going to impact the data item. It is because they are allowed to perform only read. They are reading the information. No sort of changes are made to the data item, but any of the transaction. Clear? That is why these two will be a non-conflicting operation. And coming to the next one, read operation performed by T1 and read operation performed by T2 transaction on different accounts. This is also possible because different accounts, two different transactions are reading at the same time. There is no problem at all. And coming to the third one, write operation performed by T1 transaction on B, read operation performed by transaction T2 on account A. So this is also a non-conflicting operation. And next, read operation on B performed by T1 transaction and write operation on A performed by T2 transaction. Here also the accounts are different. So whatever the operation might be made by different transactions at the same time does not lead to any kind of problem. And coming to this, write operation on A, write operation on B. Here you can see write operation on A and write operation on A made by two transactions on same account. So it is a conflicting operation. Here, write operation is same, but made by two different transactions on two different accounts. So this is not a problem. So we can say that it is a non-conflicting operations. Now let us see what is a precedence graph. Precedence graph is used in order to check for the serializability, whether the given schedule is serializable or not. It is a shortcut method to test that it is a serializable or not. Clear? Here we have two transactions, T1 and T2. In a precedence graph, we mainly have nodes. You are representing the graph with the nodes as well as edges. Whatever the nodes are there, those nodes are used for representing the transactions, and the edges define the operations made by the multiple transactions. So coming to nodes, how many number of transactions you have? In the given example, we have only two transactions. So these two transactions are represented with a circle symbol. Clear? And next, coming to edges. Edges define the direction in which the operations are executed by the transactions. Here, first read operation is made by T1 transaction on A, and then read operation is made by T2 transaction on A. And coming to write operation on A, read operation is made by transaction T1 and write operation is made by transaction T1 on the same data item. So thereby this is also not a problem. You cannot define any edge for the same transaction. So you can ignore in this case. Here at this particular point, let us say this point B at time interval 2, if read operation is made by T2 transaction on A, and at time interval 3, what happens? Write operation is made by T1 transaction on A. So first, which made the operation, whether it might be a read or write, the operation first has been initiated by T2 transaction. So after T2 reading the A, T1 has performed write operation on A. So thereby, what is the edge that you can give is, we have T2 and T1, and the edge you can define is from T2 to T1. So edges always define the order in which the operations are made by the multiple transactions. And coming to read operation on B and write operation on B, these two are made by the same transaction, so you can ignore it. Now if you see, this is our precedence graph, clear? And the edge is given from T2 to T1. From the given graph, can you find any cycle? No, there is no cycle. So if there is no cycle that is formed in the given graph, then we can say that it is conflict serializable. Conflict serializable. Clear? If you find a cycle in a given graph, if the graph is cyclic, then you can say that it is non-conflict serializable. Non-conflict serializable. What do you mean by conflict serializable? Conflict serializable means after swapping of non-conflicting operations, it can transform into a serial schedule. Clear? So that is why if there is no cycle, then we can say that it is conflict serializable. After swapping, what do you mean by after swapping is, now look at this particular table. I am making some sort of changes over here. This is T1 transaction and this is T2 transaction. So here, read operation is made by A by T1 transaction and read operation is made by A by T2 transaction. Furthermore, T2 transaction is not performing any read or write operations on A. Clear? So thereby, if I just swap these two, what is going to happen? In the place of this, I'm going to write down this T2 transaction. So first, let us assume that read operation is made by A by T2 transaction. Okay. Now, read operation is made by A by T1 transaction. Immediately, write operation is made by T1 transaction. And we are going to write the same operations on B, which is made by T2 transaction. Conflict serializability says that whenever you swap the transactions, okay, it may transform into a serial schedule. Now, when these transactions, this read of A by T1 and read of A by T2, when it is swapped, you can see the transformation of the transactions made by T1 and T2. Once the T2 has completed its read operation, T1 started completing the operations, that is read and write on A. After its completion, again T2 transaction started to do read and write operations on B. This is something like you can find one after the other, the transactions has been executed. So we can say what? It is a serial schedule. This implies what? It is a serial schedule. Clear? Where if this graph forms a cyclic, then we can say that it is a non-conflict serializable. Clear? Now let us see what is view serializability. In the previous slide, we learned what is conflict serializability, and now you are going to see what is view serializability. This is the other type which we have in serializability concept. Firstly, view serializability is one of the types of serializability in database management system that ensures the consistency of database schedule. Both conflict serializability and view serializability both ensures consistency of database in the schedule. What is the difference between view and conflict serializability is conflict serializability will matter the order of operations made by the different transactions. But where in case of view serializability, it does not matter about the order. It does not matter about the order of operations made by different transactions, right? Whatever might be the order, the thing is, finally, the result that it is obtained must be the result as we have obtained when the transactions are executed in a serial order. That is known as view serializability. Let us see. Two schedules are view equivalent if they have. To say that these two schedules are view serializable, then you need to follow several conditions. What all conditions you have to follow are listed over here. Let us read one by one and solve an example problem saying that whether that schedules are view serializable or not. Initial read. An initial read of both schedules must be the same. Suppose two schedules S1 and S2. In this example, under S1, T1 is making initial read on A. And similarly in S2 schedule also, T1 is making an initial read on A. So thereby what can you say? S1 is done by T1 and same S2 it is also done by T1. So these two schedules are what? They are view equivalent. This is the first condition to be satisfied. Updated read. In schedule S1, if Ti is reading A, which is updated by Tj, then in S2 also, Ti should read A, which is updated by Tj. What do you mean by this? We will consider this example and understand what is the updated read. In schedule 1, T3 is a transaction which is reading the updated value of A made by T2 transaction. Now coming to this schedule 2, here also T3 should read account A which is recently updated by T2 transaction. Let us see whether these two are equal or not. At time interval 1, which operation is made by which transaction? T2 transaction made write operation on account A. That is first done by T2. And next, at time interval 2, T1 transaction performed write operation on A. And whichever recent updated operation made, it is read by T3 transaction at time interval 3. In schedule 2, the last update made is T2. In schedule 1, the last update is made by T2. Clear? So therefore, we can say that they are not view equal. Final write. A final write must be the same between both the schedules. In schedule S1, If the transaction T1 updates A at last, then in S2, final write operations should also be done by S1. If the write operation on some data item is made by one particular transaction in a schedule, the same transaction should make the write operation lastly or finally in the other schedule as well on the same data item. Then we can say that the two schedules are view serializable. Now, when all these three conditions satisfies, you can say that the given two schedules are view serializable. When they are view serializable, then you can straight away say that it is a serializable schedule. Clear? Let us see an example. Before that, I am going to show you a broad view of serializability. When testing for the serializability, first we are going to check whether the schedule is serializable or not. If it is conflict serializable, then you can directly say that it is serializable schedule. Clear? If the schedule is not conflict serializable, then you have to test whether the schedule is view serializable or not. If it is view serializable, then you can say that it is serializable as well. But if it is not view serializable, then you can say that it is non-serializable. Now we have those two schedules, namely S1 schedule, and we have the another one which is S2 schedule. Here we have three different transactions, T1, T2, and T3. In schedule 2 also we have transactions T1, T2, and T3. Remember all the three conditions which you have learned to satisfy whether the schedule is view serializable. So what is the first condition we have? It is initial read condition. Let us test which of the transaction has made an initial read on account A in schedule 1. In schedule 1, T1 transaction made initial read. So initial read means before to this particular read operation on account A, there is no write operation made. So thereby we can consider that this is the initial read made by T1 transaction on account A. In schedule 1, the read operation on account A is made by T1 transaction. You have to test the same thing in schedule 2 also. So in schedule 2, read operation on account A is made by T1 again. Clear? On schedule 2, read operation on account A is made by T1 again. So as T1 is performing the same, you can say that these two are satisfying the first condition of view serializability. Now let us check for the second condition. That is what? Updated read condition. Updated read indicates what? The updation made by one transaction on some account is immediately read by some other transaction, must be same in both the schedules. Now, T3 made the write operation on account A, which means it is updating the data item A in schedule 1. And similarly, you can find the write operation is updated by T3 on the same account A. But here it is asked about the updated read. Once the write operation is made by T3, is there any other transaction who is reading the updated value of T3? No, there is nobody. T3 has made the modifications on the same data item in both the schedules. And similarly, this updated read will be equal in this particular case with the third condition. That is what? Final write. Final write. Who made the final write operation on the account in schedule 1 and schedule 2? T3 made the final write operation. And similarly, in schedule 2, T3 made the final write operation on account A. So here the final write is made by T3 as well. So thereby, as all the conditions are satisfied, you can simply say that S1 is equal to S2, which means these two are view serializable. You can straight away say that it is serializable as well. Hope you have understood today's lecture. Thank you.